Okay, 8.3, the laws of logarithms. Okay, so there's certain arithmetic laws associated with logarithms. Certain things you can and can't do, different operations, or different things that happen under certain operations. And a lot of the laws that govern the arithmetic for logarithms are similar to the laws that govern the arithmetic for exponents. And that should make a little bit of sense because logarithms and exponents have a very close relationship to one another, right? So I'm going to go through the three big laws about logarithms and then do some examples for how that arithmetic works. Okay? So let's start with law number 1. Okay? Which basically looks like this. You have a log of a product with a base. That's equal to the log of the first factor plus the log of the second factor, both with the same base. So basically what this is saying is if you have two things being multiplied together in the argument of the logarithm, that's just this part of the logarithm right here, the big numbers. If you have two things or two expressions being multiplied together, you can split those up into two separate terms, each with their own logarithm. Okay? So the proof for this, because it kind of seems like I'm pulling it out of thin air, I'm going to prove to you that this is correct using exponent laws, actually. Okay? I'm going to let x be equal to the log of big M base C, and I'm going to let y be equal to the log of big N base C. Okay? And I'm going to write each of these each of these equations in exponential form. Okay? So the first one becomes c to the x equals m, and the other one becomes c to the y equals n. You guys follow me so far? Okay. So that's just my defining statements for the proof we're about to do. Okay. The next thing I'm going to do is I'm going to take m and n and just multiply them together. Okay. Because m is equal to c to the x and n is equal to c to the y, that's technically the same thing as going c to the x times c to the y.
Is it? Oh, and
right? M times n is the same thing as going this guy times this guy. Okay? Next line, what do I do when I have the same base of two powers? What do I do to their exponents when they're being multiplied? You add them together, right? So this is c to the x plus y, technically. Still m times n, right? Now what I'm going to do is I'm going to take this whole statement and rewrite it in logarithmic form. Okay, c to the x plus y is equal to mn. All right, in logarithmic form, that becomes log base c to the x plus y equals mn. That doesn't look like mn. mn. There we go. So all I've done is I've taken this equation and wrote it in forgot how to spell logarithmic. Logarithmic, there we go. Form. Still with me? Now in my original definition, I had defined x as the log of m base c, and y as the log of n base c. So I'm going to make a substitution for this x and this y using those expressions above. Okay? So this becomes, the left side doesn't change, I'm not making any substitutions there. This becomes the log of m base c, which was what x was, and then plus the log of n base c, which is what y was. So all I did is I replaced x with this expression and y with that expression. And there we have our final statement. Okay, believable? So, once again, when you have two things multiplied together in the same logarithm, you can split them up into two separate logarithms summed together. Okay, and I'll show you some examples of how that works when we get there. Alright, the second law looks like this. It says, should do it in red, the log of m over n. This is a quotient inside your logarithm. That's the same thing as going the log of the first upper term, or the numerator, minus the log of the denominator, n. So it's similar to the previous law, except you're dividing your arguments, and that gives you the ability to subtract two separate logarithms, one with the numerator, one with the denominator. Okay, I'm going to omit the proof from this one, but it's very similar to the last proof that we did. It just follows basically the same guidelines as what we did before. You can check page 394 in your book at a later date if you want a little more assurance as to how that works. And then the third law, which is probably the least intuitive one, but I would argue one of the most useful ones, is whenever you have a logarithm with an argument that has an exponent, okay, this guy up here, this p up in your exponent, that can become the coefficient of the entire logarithm. Okay, so you can basically just move this exponent in front of the logarithm and it will become the coefficient, and vice versa. You could take any coefficient of a logarithm and put it as the exponent of your argument inside of your logarithm. Okay, and again, if you want to take a look at the proof, this one's on page 395. If you need some more assurance there. Okay, so these are some of the laws that govern the arithmetic for logarithms. Okay, and we're going to do some examples for how to use them.